Today we're going to go over how to transform all parent functions. So the idea is that you know the parent function and can graph that very easily, really, whether it's absolute value or square root, that you know where the parent function points are. And we start from there. And so I'm going to just start with, I'm going to put them all together. You're going to have all the transformations right here in this one little map. So I'm just going to start with a function. I'm going to be real specific, and I'm going to start with a function that's squared. So I'm going to start with the quadratic, something that you are really good at graphing already. So you know you have your parentheses, and this is squared. So there's like your main kind of function. Probably the easiest transformations occur outside the parentheses. So where positive moves the graph up and negative moves the graph down. Now, inside the parentheses, you're going to have a variable, whether it's parentheses or brackets or square root sign, whatever. You're going to have a variable somewhere. That's what creates all the different points. Inside moves left and right. Anything inside is kind of opposite or reciprocal. So this is actually opposite. So plus, usually we would think to the right, but plus, as you know, moves it to the left, and negative moves it to the right. Now, there will be a number out in front here, possibly. We'll go over that in a minute. The next thing you're probably really very good at, and there's also going to be a sign here, is the number out in front of this. These are the things you did in Algebra 2. And this would be your vertical. Stretch or shrink, you can use compress, expand, stretch, shrink. So it's up to you. If this number, and I'm going to call the number C, if the number is greater than 1, then it's going to be a vertical expand. If this number is between 0 and 1, now we don't care about the sign, that's why we stop at 0, the sign does something else. This is a vertical compress. And again, our book uses expand and compress. You may like shrink better if you want to use that. So then you might also have a negative sign out here. And this negative sign makes the graph reflect around the x-axis. So it goes from pointing up to pointing down, let's say. Now inside here, this is going to control horizontal. Now remember I said inside the parentheses or the brackets, things get weird. They end up being opposite or different. So this, first thing you want to do is you're going to take the reciprocal. You definitely want to take that number, whatever it is, and you want to flip it. If it's a fraction, flip it. If it's a whole number, flip it. So do the reciprocal. And if you do the reciprocal, then the rules are the same. If that number is greater than 1, this is now going to be a horizontal expand or stretch. And if that number is between 0 and 1, this is now going to be a horizontal compress or shrink. There's an R in there. Now, you could also have a negative sign inside the parentheses, which is not something that happened a lot in Algebra 2, but you'll see it more now. This is a reflect over the y-axis. Now, for a lot of graphs, when you're reflected over the y-axis, it really doesn't change much. So sometimes that's a little bit hard to see on the calculator, but we'll go through that. It still doesn't happen very often, but you're going to see it. So let's just go through some of these and practice. I'm trying to leave that up there in case you need to see it. I guess you could hit pause. So if our parent function is the square root, and we're just describing these transformations, there's no particular order. I'm going to go from left to right. So this is outside of the bracket. This is the radical sign, the parentheses, whatever you want to call it. So this is just up 2. This is going to be inside or underneath the radical. So this is now your left or right, and minus is right. And you have to say how many. You don't have to use units. You don't have to say, transformed or moved. You can just give me the direction and the value. Now here we have 3. So anything besides the radical sign and the x has to be described. So we have a negative, a positive 3, and a positive 1. I'm just going to go in order from left to right. So the first is a reflect over the x-axis. Then, of course, the 3 is going to be left 3. And the 1 is up 1. So those are all things that you've seen before, just a quick reminder review of some stuff that you know. Now, what you're maybe not as good at are these rational functions. We will go over rational functions in detail on their own later, but they're going to sort of creep in here in the next couple weeks. X to the negative first is really a reciprocal. This is really just saying 1 over x. Any negative exponent shoves the number to the bottom. And of course, the 4 is just a plain 4. So this is really the same thing as 4 over x, if that helps. So the 4 is on the top. And with rational functions, we have a numerator or denominator. We don't really have in front or behind or in the parentheses. The numerator is your vertical. So this is going to be a vertical stretch of 4. Right now, you just have to be able to recognize these. We're not going to do too much with the graphs. So this is a little bit easier to read because you can see the parent function in there a little bit easier. So this is reflect over the x-axis. And of course, up 5. Something else we're going to do today is even and odd. Again, just a quick review of some Algebra 2 things that keep coming up in pre-calc. So it says these are even graphs. What type of symmetry do they have? So if we put these, lost number 3, sorry. These are odd graphs, there we go. It says using your calculator, put these in the calculator. If you don't have a calculator handy, this one is kind of narrow, has a vertex at 0, 0, looks like this. This, of course, you better know, absolute value, parent function. Make it more pointy, make it more obvious that these are two sort of straighter sides than the quadratic or the quartic that you see on the left. So these are both have symmetry with the y-axis, meaning if you folded this right on the y-axis, the two sides would match up. All right, so even goes with symmetry with the y-axis. Now we're going to graph these two. Parent function of this you should know as well, without being too specific with our points. That's going to look like this. Now part B, this one is crazy looking, and my graph may not be too super accurate, but it's kind of comes up. It kind of does crazy stuff like that. Now it's a little bit hard to show on this video, but if we were to take the calculator and just sort of spin the calculator around, you would see that the graphs look the same. So if you spin your calculator and turn it completely upside down, the graph looks the same as when it did was right side up. That's not true for the ones above. So these have symmetry with respect to the origin. Now you got to be careful with just taking the shortcut. And the super shortcut is to just look at the powers, like all these powers are odd. So you go, oh, so that must be odd. Okay, so if we look up here, all these powers are even, so the graph must be even. When you run into something like this, the absolute value, that is x to the first. That is an odd power, but yet the graph is even. So please be careful. Don't just look at your powers. You're going to get fooled on some of these that are not just polynomials like we have for A and B, the ones that I circled. Those are polynomials, which is why you can tell. When you have other graphs, it gets a little crazier. So be careful. So the best way to do it is, of course, algebraically. So we're going to evaluate f of negative x, or plug in a negative x for 5b. So we're going to do, I'm going to rewrite this because when you use substitution, you better use parentheses or it changes the meaning. So we have negative x like that to the fifth, not negative x to the fifth, because that looks like opposite of x to the fifth, which is negative, which is not what we want. All right, so you want to make sure it is still going to be negative, but you want to make sure that you use parentheses when you substitute, and you'll see why when we get to part 8. So we have negative 3, negative x to the third this way, plus 4 times negative x. So we're going to simplify this. It's negative x to the fifth. This is a negative times another negative, so it's positive 3x to the third. And a positive times a negative is a negative 4x. As you can see, it came out the opposite. did not come out the same. Every single sign is the opposite of the original. Whereas if we do the even function, or number 3, we were going to have 2 times negative x to the 4th. Now that's different than this. This is negative, where this one's positive rather, where this one's negative, sorry, where this one's going to be positive up there. Get rid of all this. And then we're going to have plus negative x quantity squared. So if you're asked to show it algebraically, this is what you do. So this is going to be 2x to the 4th plus x squared. They both end up being positive. So to kind of summarize what's happening, because I just sort of put it all out there with examples, not really summarized it very well. So if you have an even function, first of all, your graph has symmetry with respect to the y-axis, folding, and when you plug in a negative x, it comes out as the same as the original. The signs do not change, they match. But if you have an odd function, then the graph has symmetry with respect to the origin, or is a 180-degree rotation. You spin it rather than fold it. And when you plug in a negative x, you end up with the opposite of your original. All the signs are opposite. Now, as far as the transformations go, if you have to draw the graph, and you will, without the calculator, and you will, this is the order that you have to graph it in. Otherwise, the graph could turn out to be incorrect. It could be in the wrong quadrant, or it just could be an incorrect graph. So this is the order. We want to go left and right first. So go left and right. Then you want to do anything that's multiplying. So then you want to do all of the stretch or the shrinking or the compressing, however you want to call it. So we go left or right. Then we deal with stretch or shrink. Then you want to deal with reflecting. So anything with negatives. And the very last thing you want to do is move it up or down. So while moving it up and down might be your best thing, you might be best at it, save your best for last. So we're going to move it left and right first. Then we're going to do the hardest one, which is to stretch or shrink or multiply. Then you reflip it over either axis, whichever one, and then you move the thing up or down. So now when you're asked to describe a transformation, the graph, or the directions say to do it in the correct order. Now we're not going to draw the graph. This is just practice when we do, because that's what's going to be next. We will do that in class together. So for this, we want to make sure you look for the left and right first. We don't have any left and right, no parentheses, no left and right, so that's good. Then we want to do stretch or shrink. So we have a fraction, we have multiplying, so this is going to be vertically, because it's outside the x, no parentheses. It's a fraction, so it's compress by 1/4. You want to say shrink, but you got to say vertical. Then, of course, the next thing is the reflection. We do have a negative sign, so it's going to reflect over the x-axis. And then finally, we would move that thing up 6. Now for this one, we do have parentheses. In this case, we have both parentheses and absolute value. So we have to deal with inside first. So that would be left 5. So here's an example of a number in front of the x. It's a 3. First thing you want to do is you want to flip it over. So we're going to think of it as 1/3. 1/3 is a small number, so that's like the one above. So it's a shrink or a compress, but it's horizontal because it's inside. And I'm keep using the word compress because that's what your book does, but you can use shrink. And of course, you want to refer to that as a fraction. And then we get to the down 2. So for the last one, we don't have parentheses, but the radical sign acts as kind of the internal part of the function. So this is a left and right, so this is going to be right 3. And of course, then we have a number that we're multiplying by, so this is a vertical stretch of 2. Please make sure you do your homework. It's on a separate paper. You can use your calculator on that if that makes it easier to draw the graphs and determine if it's even and odd. And that will be, I will post the answers to that on Google Classroom.